Let us calculate the acceleration of the body, where we know. Now comes the interesting part of the numerical. Now I am striking it with a cricket bat and it is returning back, rebounds. In this case, first I will calculate the acceleration. Hello students, this is SD Sir again from the Temple of Excellence, Vidhyaashram, Pre-University, Mysuru. Hope you have come prepared, well prepared for today's session. Today's session I have problems which is a correlation of concepts from motion in a straight line and laws of motion. The first one. The problem says a force of 98 Newton acts on a body of mass 10 kg which is at rest. Very clearly, the body is at rest. Calculate the velocity at the end of 5 seconds and distance traveled by the body in 5 seconds. As usual, we will collect the data first. So the data says the force acting on the body is 98 Newton. A force of 98 Newton acts on a body whose mass is 10 kg and it is at rest, which means initial velocity is 0. I have to calculate the velocity at the end of 5 seconds. Distance traveled by the body in 5 seconds. To begin with, let us calculate the acceleration of the body, where we know from Newton's second law, force is mass into acceleration. Acceleration is F by m, 98 by 10. So the acceleration turns out to be 9.8 meter per second square. So as the first part of the calculation, I have calculated the acceleration, which is 9.8 meter per second square. Next, velocity at the end of 5 seconds. So V is U plus AT. So V is U is 0, 9.8 into T, which is 5. So on calculation, V turns out to be 49 meter per second. So the velocity is 49 meter per second. Finally, distance traveled by the body at the end of 5 seconds. So S equals UT plus half AT square. So this turns out to be 0, 9.8 T square. So when we simplify this, this is 122.5 meters. Again, see, just using the concepts of both motion in a straight line as well as Newton's laws, we have easily arrived at the answers. Next one, students. A truck of mass 3000 kg. There is a truck of mass 3000 kg moving with a velocity of 10 meter per second, which is accelerated by a force of 600 Newton. So there is a truck whose mass is 3000 kg. It is moving with a velocity of 10 meter per second, and it is accelerated by a force of 600 Newton. What is the rate at which the velocity increases? So what is that I have to calculate here? When he says rate at which velocity increases, it is nothing but the acceleration that has to be calculated. And how far will it travel in 10 seconds? Now, to begin with, let us calculate the acceleration rate at which the velocity of the train increases or the truck increases. So we know A is F by M. This is the basic consequence of second law. Or A is 600 by 3000. This is 1 by 5, or acceleration is 0.2 meter per second square. So I have calculated the acceleration or the rate at which the velocity of the truck increases. Now I have to calculate the distance traveled by it at the end of 10th second. Note very clearly, how far will it travel in 10 seconds? So B, S equals UT plus half AT square. So how far will it travel in 10 seconds? So U is taken to be 10 meter per second plus half 0.2. Again, on simple simplification, these are all time-saving problems. S turns out to be 110 meters. So the distance traveled at the end of 10th second is 110 meter. The next one. A certain force acting on a body of mass 10 kg at rest. Again, the body is at rest. Moves it through 125 meter in 5 seconds. If the same force acts on a body of mass 15 kg, what is the acceleration produced? So the same force is acting on the body of mass 15 kgs. What is the acceleration produced? Certain force acting on a body of mass 10 kg, 10 kg, which is at rest. So initial velocity is 0. Moves it through 125 meters. 125 meters in 5 seconds. T is 5 seconds. Now comes the interesting part of the numerical. If the same force acts on a body of mass 15 kg, andre, if the same force, very trickily, I have to calculate the force first. In this case, mass is known, force has to be calculated. I know force is mass into acceleration, so I have to calculate acceleration here, for which I use S equals ut plus half at square, from which I am calculating the acceleration. So this is 125, u is 0, t is 5 seconds, plus half a 5 square. So on simplification, acceleration is 10 meter per second square. So I have calculated the acceleration of the body in this case, from which now I need to calculate force. Force is mass into acceleration. What was the mass? 10. So this is 10 into 10, which is 100 Newton. So the force acting on a body of mass 10 kg is 100 Newton. The same force will act on the body of mass 15 kg, for which I have to calculate the acceleration. So we know F is m into a is F by m. Now 100 by 15. So in this case, the acceleration is 6.67 meter per second square. So I have calculated the acceleration acting or caused in a body of mass 15 kgs. Next one. A cricket ball of mass 0.15 kg is moving with a velocity of 12 meter per second and is hit by a bat so that the ball is turned back with a velocity of 20 meter per second, rebounds. The ball is moving with a velocity of 12 meter per second. Now I am striking it with a cricket bat and it is returning back, rebounds with a velocity of 32 meter per second. If the force of blow for 0.01 seconds, find the average force exerted on the ball by the bat. In this case, first I will calculate the acceleration, which is V minus u by t. Why this minus? Rebounds, turns back. Wherever there is rebounds, this is minus of minus u. So, A is 20 minus of minus 12 by t is 0.1, 0.01. So, A is 32 by 0.01 or A is 3200 meter per second square. Now, once I've calculated acceleration, very simple to calculate force. Mass into acceleration. The mass of the ball is 0.15 into 3200. So this is equal to 480 Newton. See? Very simple. By understanding the concepts, I have arrived at the answers. My next session will work out more higher order problems from laws of motion. Until then, have a nice time. Thank you.